So this is my video on properties of logarithms, right? And so we already learned some in 5.2 that, like for example, the log of any of 1 to any base is 0, and when the base and the number are the same, log of a is 1, that means log of 2 is 1, log of 3 is 1, and so on. And things like a to the log ax is equal to x, for example, if you take log ax, that means the logarithm and the exponential cancels off, right? And you get back the original x. So we learned some properties like that. We will learn three more properties. These are very powerful properties, and you should know them. It's called the product property, which says that the log of a product is the sum of the logs. And then the quotient property, which says log of a quotient is the difference of the logs. And this says that if you have a log of a power, then you can bring the power forward. It's called the power property. Now remember, there is no rule for something like log of x plus y. So don't ever try to expand that. That's illegal to do that. So the rule is for log of a product, okay, and a log of a quotient and log of a power. So let's try to do an exercise right away. So I want to write these logarithms in terms of natural log of 2 and natural log of 3. Okay, so first take natural log of 6. So you want to write this in terms of natural log of 2 and natural log of 3. So the first thing to do would be to write this as, we'll just state that. So to write, we want to bring in 2 and 3. So, but we can't bring 2 and 3 into 6 because 6 is equal to 2 times 3. So we have natural log of 3 times 2, so we have natural log of a product. But we know that the log of a product is the sum of logs from the first rule, right? Okay. So then this log of a product that we have here is the same as the sum, which means the sum of log of 3 and log of 2, natural log of 2. So we have broken it up into natural log of 3 plus natural log of 2, and we are done. Now look at this one. We want to break it up using natural log of 2 and natural log of 3. So we need to bring 2 and 3 into this. So the way to bring 2 into this is 4 can be written as a power of 2, 2 squared. And 27 is the power of 3, third power of 3. So now we have a log of a quotient. But from the quotient rule, we know that the log of a quotient is the difference of the logs, right? So therefore, we can write this as the log of 2 squared minus the log of 3 cube. So now we are not done yet, because this is, even though we have log of 2 and log of 3, we still have a power there. So the final answer should only involve log of 2 and log of 3 without any strings attached. So what we do is we use the power rule now. So we know that if you have a log of a number and there's a power inside the log, okay, we can bring that power forward. So the 2 can be brought forward, and 2 times natural log of 2 minus, we can bring 3 forward, and then we have 3 times natural log of 3. Okay, so 2 times natural log of 2 minus 3 times natural log of 3, and that, then we have the answer. Now let's do something like this. So you want to find the exact value of an expression like this. Well, there are many ways of doing it, but first of all, you see a log of a difference, which means you can bring this under a common quotient. So if you can write it as log of what? The quotient, by using the quotient rule, 5 to the 7 divided by 5 squared. But now you can use exponent rule, because you have the quotient of two exponents, 7 and 2, and you subtract the exponents, right? And then you get log 5 of 5 to the 3. Okay, because 7 minus 2 is actually, it's 5 to the 5 really, right? Okay. So now you can actually do something more, because you can bring the 5 forward, right? So then this becomes 5. Okay. And we know that log 5 of 5 is equal to 1 from the property that we learned in 5.2. So this is 1. So the final answer is actually 5. Okay, so we will evaluate a expression like this without any calculators by simply using the properties of log. Now let's look at another typical problem that people get for exams, and you need to expand this expression into. So what happens is now they are all in one expression, right? And you need to separate it out so that you only have log x and log y, and as long as you cannot separate anymore. So first of all, you see that it is a product of three things. So you can separate those three using the product rule as sums. So it'll be log of 7 plus log of x to the 3. So once again, product of log of a product we saw is the sum of the logs. That's what we are using again. This one, sum of the logs. So we have this. We broke it up into three sums because we have three pieces in the product. There's nothing you can do for this, so you leave it alone. But here you have a power, and you can use the power rule to bring that forward. So it's 3 log 3 of x. And here you have a 7 again, and you can bring that forward. So now you have the whole thing in terms of log x and log y. Of course, you can't do anything to this, so you leave it alone. And let's take another one. So now you need to expand this. So once again, we identify it's a quotient. So we can write that as a difference of log of the top piece minus the log of the second piece. Now this is actually 1/2 power, right? Square root is a 1/2 power. So you can think of this as 1/2 power. So you can bring the power forward and write it as 1/2 natural log of 2x squared minus 5 minus 3 times the natural log of y. But you can't go beyond that because remember there is no rule to expand something like that, right? When we have a sum or a difference inside the log. So we have to stop there. Now we are going to do the opposite of this. In the last set of problems, we learn how to to expand logs, right? But now we will learn how to condense logs. So we have something like this is already expand. Now you need to bring this under a common log. So before we do that, we need to clear the fronts. So anything in front, we need to take them up as powers. So first you take the 1/2 as a power, and then you get what? So then you get log of x to the power 1/2, right? Okay, there is no actually x plus 3 here. So and plus when you take the 3 up here, you get log x plus 1 to the power 3. And then when you have you have product, there's nothing in front. And because there's nothing in front, you have sum of log. By the product rule, the sum of log is equal to the log of a product. So what we do is we write this as x to the 1/2 product x plus 1 to the 3. So once again, we are using the product rule, okay, but we are using it. So we start from this side now, the right side. The sum of two logs is the log of the product. That's what you're trying to do here. So we have sum of two logs and we wrote it. Now we have the sum of two logs here. There's nothing in front. Okay, and then we wrote it as so. As long as there's something in front, you can't use that law. So you need to first clear the fronts. So let's go to the second one. So if you go to the second one, you have this. So in the second one, again the same argument. You need to get rid of the 2. So the 2 comes as a power of quantity x plus 2. So x plus 2 squared minus natural log of x. And then now there's nothing in front and you have a difference. So the difference of two logs is the log of the quotient. So you can bring this into common log, x plus 2 squared divided by x. And we go to the third one. So third one, 1/3 times this, but here you know what, there's nothing you can do. Before you need to simplify this first. So you need to multiply them and write this as log 2 of x plus 1. And now you can take the 1/3 up like that. So that's it for this video. Thank you for watching.